Hey everyone, and welcome to this guided walkthrough of Faasera, where intelligent automation meets data compliance and privacy, now applied to a real-world fraud detection use case on Google Cloud. Today, data lives everywhere, in legacy systems, cloud storage, databases, and now powering AI. The challenge isn't just accessing that data, yes, the way it's securing it, making it compliant, and ready for whatever comes next. Let me show you the architecture before we dive into the demo. We've got transaction data coming into BigQuery, our primary data source for this use case. From there, we pull that data into Vertex AI Workbench, where all transformations, masking, and model training happen. To ensure both security and compliance, we leverage Faasera's SDK, a high-performance engine with over 100 built-in masking rules. These aren't just simple patterns, they're mapped to global and regional regulations, supported by contextual detection, checksums, and deterministic strategies. Users can also extend Faasera with custom policies, making it adaptable across industries and geographies. Once masked, the data is safely pushed back into BigQuery and ready for secure visualization in Looker Studio. All of this happens entirely within the GCP ecosystem, from ingestion to training and to insight. All right. Let's start by looking at the data set. This is a simulated bank transactions table generated by Faasera. Data synthetic engine. It includes fields like first name, last name, account number, transaction type, merchant, transaction amount, and even the last 4 digits of the credit card. Before we even touch model training, we run this data through Faasera's SDK, embedded directly inside Vertex AI Workbench. And that's one of Faasera's biggest strengths, flexibility. You can deploy it in multiple ways, as a custom container in Vertex AI or AI Pipelines, as a Cloud Run API for real-time workflows, or even inside Dataproc Serverless for Spark native pipelines. In our case, we're using the Python wrapper for Faasera's SDK, which seamlessly integrates into our Vertex notebook environment. No extra infrastructure, no friction. The SDK applies column-level masking policies defined by our compliance matrix. Names are masked deterministically, account numbers get format-preserving masking, and credit cards are tokenized. This way, we're securing the data right at the start, before it ever touches an AI model, and that's critical. Let me show you what that looks like in practice. Here's the masked data set. Like, you can see identifiers are gone, patterns are preserved where needed, and the structure remains intact for training, because you can't build responsible AI on irresponsible data. So now that we've secured the sensitive data, let's shift gears and prep it for training. Now we move into feature engineering, the essential step before any model can make sense of your data. We take the masked transaction dataset and encode categorical fields like merchant, location, and transaction type. Normalize transaction timestamps into Unix epoch format, and simulate fraud labels for demonstration. It's like flagging 10% of transactions as fraudulent. From there, we split the data, balance the classes using Smout, and train a random forest model to classify fraud versus legitimate transactions. Now, this part's important because we're not just training any model, we're training on masked, compliant, and privacy-preserving data, all handled by Faasera upstream. And the model still learns effectively thanks to Faasera's format-preserving and deterministic masking options, which retain structure while hiding real values in an irreversible manner. You'll see in the next step how this all ties into prediction and visual analytics. Let's check out the results. Now that we've trained the model, let's talk about how we put those predictions to work. After evaluating the model, we generated fraud predictions and confidence scores for each transaction. These predictions are then written back to BigQuery, creating a seamless handoff from training to analysis. And here's where things get exciting. We connected Looker Studio directly to the prediction table. This gives us instant insights like fraud distribution across merchants and locations, daily fraud trends, high-risk hotspots, and transaction-level fraud scores, all in a single interactive dashboard. And remember, all of this is happening on masked data. The underlying values are protected, yet analytics remains fully functional and trustworthy. Whether you're a fraud analyst, a compliance officer, or a machine learning engineer, you now have a safe, compliant lens on the most critical insights. Sweet, and that brings us to the end of our walkthrough, but really this is just the beginning. What we've seen here is a complete production-ready journey from raw sensitive bank transactions to a masked secure data set to model training and fraud prediction, and finally to real-time insights in Looker Studio. All of this was powered by Faasera, a privacy-first compliance platform that integrates directly with Vertex AI. In this example, we use the Faasera SDK inside of Vertex AI Workbench notebook. But that's just one path. Faasera is designed to be flexible. So whether you're building AI models, analyzing fraud patterns, or prepping for audits, Faasera helps you do it all securely, responsibly, and without slowing down innovation. And if you're thinking about building AI with trust and compliance at the core, Faasera is ready when you are. Thanks for watching. See you in the next one. Bye for now.